Welcome back to the 27th part of Debugging at Scale, where we focus our efforts on effective tests. Debugging and testing are two vastly different subjects. There are many books on testing, and this course isn't about testing. Yet both debugging and testing have a few convergence points of interest, which we need to cover. Before we get into those points, it's probably a good place to discuss some basic testing terminology that's thrown around. Mocking replaces an object with a fake object that masquerades as a specific type while returning pre-programmed results. The clean definition of unit tests is one where we test specific method or function in complete isolation. We only test the method itself and nothing else. The inverse of that is the integration tests, which test a more realistic scenario where multiple layers of the application are running. In modern usage, these lines are blurrier than one would expect. Using too much mocking is considered problematic since it reduces the quality of the tests. Integration tests can include mocking, although this isn't as common. Unit tests are fast. This means we can run them all the time, sometimes even as we type within the IDE. They are consistent since they run on a smaller portion of the code. The trade-off is that they have narrow coverage by comparison to integration tests. Arguably, they don't test enough. Their error messages are far more readable, which is a killer feature in my opinion. Running them is usually easier as there are fewer dependencies. Finally, coverage is the metric by which we check if we have enough tests. It instruments the code and verifies that every line and statement is reached when running the tests. It produces a report which comes down to a percentage of the lines and statements covered by the tests. While quality shouldn't be measured by a simplistic numeric value, this number is often standardized by organizations. Some require 100% test coverage, which means every line and statement must be reached. This often follows a law of diminishing returns as coverage grows. What's the role of tests in the debug fix cycle? We discussed this briefly in lesson 15 about the process. When we find the cause of the bug, the best practice is to write a test, preferably a unit test, that reproduces the failure. Then focus on passing the test before verifying the bug itself was fixed. This has a couple of advantages. By adding a test, we can verify the bug won't return. Running a test is usually faster than running the entire application and restoring the buggy state. The bug fixing cycle is illustrated in this diagram. First, we find the bug. This course is about this stage in the cycle. This stage is the debugging process itself. Next, we create a test. We must create a test that reproduces the problem we encounter. A unit test is often ideal for these situations since it's faster and easier to debug. Next, we need to fix the bug. Notice that this should come after the creation of the test. You need to create a test that fails and verify the failure. This provides two important benefits. We now have double verification for the fix of the bug, the unit test, and the code. Second benefit is the automated test that will prevent the bug from recurring. We then need to run the test. Verifying the fix against the test is usually easier and faster than doing so against the entire application. Finally, we run the code. This is the final goal. We need to verify that the fix works with the actual application code. If it doesn't, we need to restart the cycle all over again. In the internal interest of brevity, I omitted some stages from this cycle. Specifically, I chose to omit version control and issue tracker processes. These are important aspects, but they're better served by a book dedicated to software quality. I discussed them in the 15th video in this course though. Typically, unit tests are easy to write. We invoke a method using various parameters and define the success criteria. The devil is in the details though. Tuning coverage numbers to higher values is challenging and very difficult. Testing a specific bug or behavior and mocking appropriately are all challenging too. Luckily, the debugger can help with the task of composing effective tests with good coverage. We can compose good tests without a debugger, but it would mean stopping execution, recompiling the tests, and running again. The basis for all of these is jump to line, which we discussed in the first module. We can move the current execution to a point before the method was executed and rerun the test over and over until we get the desired result. Think of it as a reset button that doesn't require recompilation, rerunning, and lets you create any imaginary state. We can traverse the testable method repeatedly while verifying coverage with a step over and tuning variables to suit our needs. Once we understand the set of variable values that produce the desired test constraints, we can code a unit test with those parameters. A typical test coverage report will highlight a line or a condition that isn't reached by a test. In the image here, we can see a highlighted statement whose body is always skipped in unit tests, thus resulting in a test without full coverage. By using the set value capability of the debugger, we can verify that the code is reached. In this case, you will notice that the next line in the body is a reject value call, which will throw an exception. I don't want an exception thrown, as I still want to test all the permutations of the method. I can drag the execution pointer arrow on the left and place it back at the start of the method. This example is relatively trivial, but when we're faced with complex conditions within a method, we need all the tools we can get. We can detect the right objects that need mocking for an invocation by stepping over and inspecting. Using a debugger to review the implementation would make the things easier. When building a real-world application test, the process of back and forth rerunning and calibrating the tests is tedious. The debugger can make this so much easier. This approach has one theoretical drawback. It can couple the implementation and the tests. I'm from the school of thought that accepts this situation in the case of unit tests, but some would disagree. Testing is a tremendous tool for debugging. In the next video, we'll discuss test-driven development, the good, the bad, and the ugly. If you have any questions, please use the Slack channel to ask them. Thank you.